on sample paper 3, level 2. So let's begin. Let's get a pen here. So the first question is about a flight competition. So people are going to Sweden and they got to pay 35% of the cost as a deposit. Well, the cost is 895. To work out 35%, we divide by 100 and we times by 35 to work out how much money they put down as a deposit. So to do that, we'll jump on the calculator here. I'm going to do 895 divided by 100 times 35 to work out 35%, and we get £313 and 25 pence. And the question says, what's the amount left to pay? Well, the amount left to pay is what you originally should have paid minus the money you've put down as a deposit. So that would leave £581 and 75 pence to pay. So a nice little percentage of amount question, very popular in the exam. Now we have to change some money from the Swedish krona. So we're changing Swedish krona. Seems to be we're changing it to pounds and to dollars. So we'll write out, we'll do the pounds first. So £1 equals 10.68 Swedish krona. And I want to change 8,500 Swedish krona. So I'm going to put it over there. Right. As I'm going back on myself, because my answer is going to be over here, I am dividing. If we're in reverse in maths, we're dividing. Also, I expect the answer over here to be roughly 10 times smaller, as this number is roughly 10 times smaller than the number over here. So we'll take 8,500 and we'll divide it by 10.68 on a calculator. So 8,500 divided by 10.68 equals 795.88. Next, we have the dollars. So again, 1 Swedish krona equals 0.12 dollars. So I'm going to do 8,500. And this time we're going this way. This side is 8,500 times bigger, so expect this to be 8,500 times bigger as well. Going forward, we're multiplying. So it's 8,500 times 0.12. So again, we get a calculator. 8,500 times 0.12 is 1,020. So dollars was 1,020. All the dollars there. And the pound was 795.88. So any sort of metric and periodic conversion, such as money, etc., is always a popular question in the exam. Now it says do an inverse check. Well, I'll take one of these answers. I'll just take this one, 1B. It said do any calculation. Well, what we do is we write down the sum we originally did, so the examiner can see our work. And then we'll do a reverse check. We'll take the answer, and instead of dividing by 0.2, I'll do the opposite. I'll multiply by 0.2, and I should get back to where I started from. And there we go. Next, we've got a time question. So people are getting a flight. There's it there. We're going to work at the time difference between New York and Gothenburg. Right. So the flight leaves at 8 o'clock and arrives at 2 o'clock. So that is 6 hours. So 8 o'clock in New York is 2 o'clock at the same time, but 6 hours ahead in Gothenburg. So the time difference is 6 hours. 1400 take away 0800 is 6 hours. Now it says you want to work out what time the flight will land in Gothenburg. We know there's 6 hour difference between them, so we'll have to take that into account. Well, it's suppose it leaves New York at 3:30, 15:30, and it takes 9 hours and 30 minutes. I'll take the 30 minutes away and I'll get to 4 o'clock. If I add 8 hours on, I'll leave me 1 hour left. That'll bring me to midnight. 4 plus 8 is 12. I still have 1 hour, so that's 1 a.m. But let's not forget the time difference. It's 1 a.m., but because Gothenburg is 6 hours ahead, we add 6 hours on to bring us to 7 a.m. The a.m. should be written in as well. Next, we have a scale, so it's 1 to 10,000. So this is the most important thing here. This means in paper, every centimeter we have here is worth 10,000 centimeters in the real world. So whatever measurement we do, we multiply it by 10,000. So let's take, and then we plan our route. So start the hotel. There's a hotel, and next place we go to is the city park, and that's it there. So I'm going to count the squares. You can use a ruler to count the squares. That's 1, 2, 3, 4, 5, 6, 7, 8 squares are 8 centimeters. So 8 centimeters to the city park from the hotel. And I would continue on, just do that for each place we're looking to. Next place is the city park to the Viking boat. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's 14 centimeters. And you get marks for writing each one of these measurements down. I'm not going to do them all. I'm just going to use my scale. So remember, it says work out the distance. That's the actual distance in meters. Well, on page it's in centimeters, so it's small. So we need to scale up as we're going from paper to the real world using the scale factor. And the scale factor is that every centimeter on your paper is worth 10,000 centimeters in the real world. So the answer there is 80,000 centimeters. The only problem is the answer is now in meters. So we'll take our centimeters, because remember scale is always centimeters unless you're told something different. To change centimeters to meters, I divide by 100 and I get 800 meters. Take the next example, 14 centimeters. Again, we'll scale up using the scale factor. Every centimeter is worth 10,000 according to this. That gives me 140,000 centimeters. Again, I want to get that to meters, so I'll divide it by 100 and I get 1400 meters. Now the Viking boat. And you just continue on. And eventually you'll get an answer. So I may as well work them all out. So Viking boat, and then we're at the Viking boat and want to go to the, where are we? The fish market. So there's it here. So fish market, Viking boat. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15, which will give me 1500 meters, as I know that from the previous questions. The fish market, we want to get to the cafe. I think we've done something wrong there, possibly. So fish market, back to the, we're at the fish market. Oh, I want to go to the cafe for a meal. All right, so should include it in there somewhere. I'm not going to worry about it now, but we'll get our answer. If our answer is 4,600 meters, for example, and we're asked to change that to kilometers, we would divide it by 1,000 and get 4.6 to get it to kilometers. Next says a typical person walks at a speed of 5 kilometers an hour. How long does it take to walk each of the distances? So we take the first one. The first one is 800 meters. Well, there's 800. Time equals distance divided by speed. So I'm going to take 100, and then this is meters, this is in kilometers. So I'm going to just turn that to meters by multiplying it by 1,000, and then I'm going to times my answer by 60. And I'll do that on a calculator. I take 800, I divide it by 5,000 because I've turned it to meters, and I times my answer by 60, and I get 9.6 minutes. Or what you could do is 5 kilometers, which is 5,000 meters, or just leave it at kilometers, 5 kilometers in 1 hour. Well, 1 hour is 60 minutes. Well, if I divide both these sides by 5, I'll get down to 1 kilometer equals 12 minutes. And I've got myself a little conversion factor now. So anything I have in kilometers, If I multiply it by 12, I'll get my answer. Well, 800 meters is slightly less than a kilometer, as there is 1,000 meters in a kilometer. So if 800 is 0.8 kilometers, so I times that by 12, I get 0.6. 1,500 meters, I think, is the next one, possibly. So again, it's 1.5 kilometers. And if I times that by 12, I will get 18. And I'll just do that for each one. So there's more than one method there. So you want it to be 500 meters west of the museum. So you're going to mark something in. It's 500 meters west of the museum. That's the museum. That's west. What is 1 square worth in meters? So it's in centimeters. If I divide this by 100, that'll tell you what this is worth in meters. And it's worth 100 meters. So that means each square is worth 100. Well, we have 500, so that's 1, 2, 3, 4, 5. So it'll be here. Now, our tree diagram. So they want to get a kit bag, it's a raffle, and they want to win it 2 months in a row. Well, as a tree diagram question, it asked us to draw it. So you can win a kit bag, or you can win something else. The chance of getting a kit bag is 1 out of 4. There's 4 chances, and only one of them is a kit bag. The chance of not getting a kit bag must be whatever's left. There's 3 things left out of 4. Now the next month you want to win a kit bag again. So kit bag. Or you can win something else. Now the raffle has restarted, the prizes have been put back in, so nothing changes. And we should look like that. Next, we have to work out the probability of winning a kit bag. Well, it's kit bag. It's got 2 fractions beside it. We write them down. 1 times 1 is 1, 4 times 4 is 16. So we multiply them. You're training with a running partner. We're going to draw 2 trend lines. So we're going to follow these trend lines. Here's this one. So most of the points are generally going down this way. So we could start at the first point, roughly head down towards the last point, trying to keep an even number above and below the line. That's not too bad. Here, most of the points are kind of running this way. So we don't have to start in this point. We can start near it. It has to be a straight line. And we get it as best you can, a straightish line running there. You got an even number of points. 1, 2, 3, 1, 2, 3, above and below the line. Now it says make sure the straight lines draw with a ruler. It said write 2 comments to compare, and very few people compare JJ's with your results. Well, you and JJ. So JJ is here, and you can see his times are getting better the more practice sessions he does. And your times are also getting better, but slightly better than JJ. So both times, oh dear, times getting better. You quicker. You're getting quicker than JJ. So you have to give 2 comments comparing folks, not just one individual comment. You got to mention the second person in each comment or the trend. Here we have a formula. For this formula, we've got to use information from our graph. It says P, we write the formula down, P equals 1.36. There's no space between the letters and the numbers, so it means multiply. Most important rule. T minus F times W. Well, P is what you're looking for. P is going to be your predicted time. And we know it's 1.36 times T. T is the latest practice session in hours. So if we go back to our chart, it says practice sessions. And the latest must be the last one. So I'll just do me first. There's you. That's myself. So there's 1.5. That's 2. That's probably 1.6, 1.7, 1.8, 1.9. So I'm going to take that figure. I'm going to minus it, minus F, which is It does tell me the improvement factor. But for me, the improvement factor is 0.12 times W, which is the number of weeks. And there we go, 3 weeks. And that's my formula ready to go. So I get a calculator. I do 1.36 times 1.9, and I get 2.584. And we just take away this, we multiply it first, 0.36. Just do it in the calculator, 2.584, take away 0.36 is 2.224. Then you answer the question, will you achieve, I'll do the first person, once you show the first person, you should be able to do the second. So will you achieve the target time? Well, the target time was 2.5 hours, and 2.224 is just under 2.5, slightly under there. So yes, you would achieve the target time. As you would say, it's under the 2.5 hours time limit. And you just repeat this for JJ then, using the same thing. The only thing the difference is his calculation is slightly higher. So his latest time was 2.1. And that's the only part of the calculation that would change. Here you got to work out the medium, and the medium is numbers added up and divided by, no, the medium is put the numbers in order first, smallest to largest. So this is going to be quite a slow process. So we have 1.50.48. That's that one. What comes next? We've got 15324. We've got 15548. We've got 203. We have 204. If anybody can read my writing with this pen. 204.12. 205. 24. 211. 24. 212. 12. 214. 24. Slow process this. 218. 36. Nearly there. Did we miss one? We'll check at the end. 218.36. 252. 12. 313. 12. 352. 48. So we should have 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've made this very messy. I'm going to have to rub it all out. And look at it again. Drawing it properly this time. So I had 1, 5, 3, 2, 4. So just fix these up a little bit to make it easier for us. We line them up, put them in order from smallest to largest, which was difficult. And then we tick them off bit by bit till we come to the middle. Just like so. Makes your life a little bit easier. And in this case, we've got 2 in the middle. If you get 1 in the middle, great, you write it down. If you get 2 in the middle, you add them up and divide by 2. So we have 2, 12, 0, 0, and 2, 12, 12. Well, if you look at this, those two numbers are the same. The only difference is these two. And the halfway point between 12 and 0 is 6. So the medium there would be 212 because they don't be touched, they weren't affected. The only difference is here, which would be 0, 6. It says compares JJ's predicted time with the results from last year's half marathon. Make one comment, include figures to support it. JJ's predicted time. Well, we didn't work out JJ's predicted time, so we've got to work it out now. So his predicted time would be P equals 1.36 times his time, his latest time, which was, there's it there, 2.1. Minus the improvement factor and the number of weeks, which is 0.06 times 3. Well, 0.06 times 3 is 0.18, and 1.36 times 21 is 2.856. Let me take one away from the other. And we get 2.676. So compare the results from last year. So his predicted time was 2.676. The results from last year's marathon was 2:12:06. That was the average for the people who ran it. So what would you say? Well, his results are a lot greater. He's a lot slower. So you'd say JJ was a lot slower. His predicted time is a lot slower than the time from last year's results. Range. So the range is the highest. I think it's 35248. There's it there. Take away the lowest. I think that's the lowest there. Not. Oh, sorry. 1. Let me rub that out. 1:50:48. So take one away from the other. With 48, take away 48 is easy. 0, 0, 0. 52, take away 52. With 2, take away 0 is 2. 5, take away, no, 5 is nothing. 3, take away 1 is 2. And we write it like that, like a time. So it's 2 hours and 2 minutes. What's the tally about the times for the runners? Well, 2 hours and 2 minutes is quite a difference between the person who finished first and last. So I'd say it's high. The range is high, which means inconsistent. That little word again, inconsistent. So range is high, which means inconsistent. So we're asked to draw a bar chart. A chart doesn't say a bar chart. Says chart, or says R graph. So we could draw a bar chart or a line graph to show the total amounts raised each year. So that's this here. And they're going up in thousands. Biggest number is 7,400. Well, there's not. Well, every 2 squares of 1,000, what I make it? I'll need 14, maybe 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14. So write in your numbers. I'm just going up in thousands here every second square. Writing them in. 7,000 and then 8,000. It says first one's 2,700. There's 2,000. There's 2,005, 2,700, and draw in. Then we have 4,200. Leave a space. 4,200. There's 4,000. There's 200. Make sure to, oh dear, use a ruler. 6,000 for the next one. There's 6,000 there. To make a 7,400. 7,400. And then we draw them, and you would use a ruler in the exam, obviously. And then we put in our categories and labels. So with years here, 2013, 2014. etc. Write the word years, make sure to label it. Up the side we have money, total raised. So total, or something like that up the side. That's your bar chart. Listen, thanks for watching this video on sample paper 3, level 2.